Okay, this is problem number 5. Problem number 5 reads, new photo imaging techniques on computers allow artists to distort an image from its original shape. Figure 1 is a square image of the Facebook logo. Figure 2 is the logo shrunk 6 units narrower and stretched 6 units taller than Figure 1. How many square units greater is the area of Figure 1 than the area of Figure 2? So we're dealing with area here. I'm going to have two columns right here. I'm going to have a column for Figure 1 and a column for Figure 2. So area, as you probably remember from middle school, area equals length times width of a rectangle. So in Figure 1, it's actually a square, so the length and the width are the same. So instead of multiplying numbers together, it gives us an expression for the length and the width. And in Figure 1, it's x. So the area of this square is length times width, and both the length and the width are represented as x. So x times x, and we can simplify that to x squared. So x squared is an expression for the area of Figure 1. Let's look at Figure 2. Again, Figure 2 is a rectangle, so the area of the rectangle is length times width. So I'm going to substitute now. The area equals. Now the expression for the length in Figure 2 is not x, but it's x minus 6. It's smaller because it was shrunk. So it's whatever x is minus 6 units. So I'm going to put parentheses x minus 6 times the width, which the expression tells us it was stretched taller 6 units, so it's x plus 6. So now we have multiplying two binomials, which we are going to use our FOIL method. Again, FOIL is just a reminder of kind of the order that we can multiply these two binomials. So f stands for the first term, so x times x is x squared. The outer terms, x times positive 6 is positive 6x. The inner terms, negative 6 times x is negative 6x. And the last terms, negative 6 times positive 6 is negative 36. We can simplify this one more time by combining our like terms, which are x terms. So I'm going to rewrite this as x squared. Positive 6x and negative 6x, those cancel out. I don't even need to write it. So my resulting simplified expression is just x squared minus 36. So the expression for the area of Figure 1 is x squared, and the expression for the area of Figure 2 is x squared minus 36. So the question asks, how many square units greater is the area of Figure 1 than the area of Figure 2? So the area of Figure 1 is bigger, it's x squared. The area of Figure 2 is whatever that is, x squared minus 36 units. So the area of Figure 1 is bigger by how many units? By 36 units, by 36 square units. Our answer is 36 for this problem. Now that might be a little bit hard to conceptualize in your brain, so let's give a quick example. Let's say that x is 10. If x is 10, for Figure 1, I'm going to redraw it. It's a square. That means each side is 10, because each dimension is x. So if x is 10, both the length and the width of the square are 10. So now my area is length times width, or in this example, 10 times 10. So the area is 100 square units. Now what about Figure 2? Figure 2 was distorted a little bit. It did not have the same length and width. The length is x minus 6. So whatever x is, subtract 6. So because we chose, for this example, that x is 10, that means that this length right here, 10 minus 6 is 4. Now the width of this rectangle was stretched taller. The expression is x plus 6. So whatever x is, add 6 units to it. So we've chosen that x is 10, so 10 plus 6 is 16. So now my area for this rectangle is, again, length times width. The area is 4 times 16. The area is 64 square units. So the question asks, how many square units greater is the area of figure 1 than the area of figure 2? Well, as you can see, the area of figure 1 is 100, so it's 100 minus 64, which equals 36. So the area of figure 1 is 36 square units greater than the area of figure 2. And we did this example by picking just an example for x is 10 to show you that the difference is 36, but that is the exact same number that we got just by comparing our expressions x squared and x squared minus 36 when we were calculating our area for the expressions for area for figures 1 and 2.